So 12a is pretty straightforward. It's just your basic rules of derivatives. Okay, so first of all, differentiation is just another word for take the derivative. It's just differentiating with respect to x. So sometimes people get kind of confused about the word derivative, differentiation, differentiating. It all just means derivative. Take the derivative. We're just going to learn all the shortcuts to taking the derivative. So we have 4 basic rules that we're going to start out with. Now, first of all, I want you to think about how the derivative is the gradient function. It's the slope. So this says if we take the derivative of a constant, let's think about this. Say that I have the equation y equals 2. That's just a horizontal line. What's the slope of all horizontal lines? Because the slope is 0 all the way across the derivative of any constant. So this c here is really just any value of a constant. So like if we take the derivative of 2 equals 0. If I take the derivative of negative 1, it equals 0. The derivative of any constant always is going to be 0 because it has a 0 slope. All right, so let's think about this before I go on to actually show the new rules. Y equals 2x minus 1. What's the graph of this? Just a line. And what's the slope of the line? 2. Then we say the derivative of this equation is 2 because this is a constant slope. So all lines, this is your derivative. Say that y equals x squared, I'm just going to tell you the derivative is 2x. If we start with y equals x to the third, the derivative is 3x squared. So what's the comparison? 2x turns to 2. X squared turns to 2x. X to the third turns to 3x. So anytime we're taking a power, a variable to a power, you basically drop the exponent in front of the x and subtract 1 from the exponent. That's why the derivative of x to the third is 3x squared. Now, say that I have a constant times some function u. I'm just going to take the constant times the derivative. So for example, if I have 7x squared, that is 7 times the derivative of x squared. Well, what did we say the derivative of x squared is? 2x. So 7 times 2x is 14x. So this is like a long process. Technically, you're taking the exponent times the coefficient, 14, subtract 1 from the exponent. Sum and difference rule. If you have 2 functions being added, you do each derivative and add or subtract according to the equation. So here's a general equation, and they've spelled it out exactly like I just did. So let's look at this one. F prime of x equals, take the exponent times the 5, the coefficient, 15, subtract 1 from the exponent. Because this is plus, I'm going to add 2 times 6, 12, subtract 1 from the exponent, minus the derivative of any linear function is just the 3. Derivative of a constant is 0. So notice the relationship between the exponents and the derivative. Everything's just 1 less. Okay. Now, in letter B, first I'm going to rewrite the equation. I want everything being a power. When I have things in the denominator, we're going to move them up. So 7x stays the same. And it's really important to actually write this as f of x because we're not doing the derivative yet. We're just rewriting the original function. I want to bring x up to the numerator, which means I have to make the exponent negative. I want to move this x up to the exponent, making the exponent negative. Now I'm ready to take the derivative. This is why I think it's important. This was just rewriting it into using power functions. Now I'm ready to take the derivative. So this is just, technically I'm taking my exponent of 1 times 7, which is 7, and the x goes away. Negative 1 times negative 4 is positive 4. What's negative 1 minus 1? Negative 2. Negative 3 times positive 3, negative 9x, negative 3 minus 1, negative 4. Now, I will tell you, you can leave it like that. Once we go to evaluate, though, it's going to be important that you rewrite this back. But this is totally fine the way this is. All right, so let's think about how we can rewrite this part. What if I want to write x to a power? Do you remember what the radical, how we rewrite that? X to the what power is the square root? X to the 1/2. Remember, this is the square root, so I move the root number to the denominator of the exponent. So this is really important to understand that the square root of x equals x to the 1/2. And I have to move this up. Now I'm ready to take the derivative. I always want to rewrite, if I can, using powers. Take 1/2 times 3, which is just 3/2. 1/2 minus 1. Negative 1/2. Negative 1 times 2. Negative 2x. Negative 1 minus 1. You're always subtracting 1 from the exponent when you take the derivative. Now, let me just show you what this would look like if I wanted to rewrite this. So if we moved everything back to the denominator, the exponents just turn positive. And remember, the 1/2 power we can also write as the square root. Now, I'll tell you that this is fine as a derivative function. All of these are equivalent functions. They're all the same thing. This is the important one to get to, though. Okay, let's take this in steps. The x squared's fine. This is x to the 1/2 in the denominator. Then I have to move it up. And this is still the original function. Now I'm ready to take the derivative. So bring down the 2. Negative 1/2 times negative 4 is positive 2. Negative 1/2 minus 1, negative 3/2. And I'm okay with it written like that. If you want to move that back down, you can. Either way is fine. Now, this wants the gradient to the tangent, which means take the derivative when x is 2. All right, so first I want to rewrite the equation using exponents only. Then I can take the derivative, bring the exponent down, subtract 1, bring the exponent down, makes it a positive 4, subtract 1. When you evaluate, I think this is a lot easier to move the x to the negative 2 back to the denominator, because now we're going to find the gradient. The gradient is your slope, and we're finding that by plugging 2 into the gradient function. So I'm just plugging this number in for each x. 2 times 2, 2 squared. This is just 4 plus 1. This tells me my gradient is 5. So if y is 3x squared minus 4x, dy dx equals, this is just take the derivative, 2 times 3 is 6, x to the first minus 4. Interpret the meaning. So with this equation, this tells me the gradient function of y. This is the gradient function, and then we can use this to find specific slopes of the tangent line all the way through this original function.